Hi, pre-calc students. We are going to go over the Chapter 6 review. So this is 6.3 through 6.8, which is graphing trig functions and applications. So let's look at the first couple here. So amplitude. So remember, amplitude is kind of that A term that comes in front. But really the only ones that have amplitude are sine and cosine. I know there's numbers in front, in front of tan, cosecant, secant. That does make them flatter. It does affect the graph, but they really don't have an amplitude. So for number one, if I'm looking at the amplitude, I'm going to say 2. If I'm doing number 2 and I'm looking at the amplitude, I'm actually going to say none. Okay, because remember, a tan graph looks like that. So even though there was kind of a vertical shrink, it doesn't change the height of the graph. It goes on infinitely. All right, I'm going to go next to the vertical shift because these are kind of the two easier parts. This is related to D here. So the vertical shift for number 1 is negative 18. Vertical shift for number 2 is 13. Okay, period and phase shift. So period for sin, cos, cosecant, and secant is equal to 360 degrees or 2 pi. Whereas if we have the period of tan or cotan, the period is 180 or pi. So that's what the typical period is. Now the way we find the period is we take the typical period divided by B. And B is this number here. B is this number here. Okay? So typical period of cosine is 360 or 2 pi. Now notice they have radians there. So if it's radians, it's going to be in terms of pi. So typical period of cosine divided by B. Well, B is 3. So what is the period? 2 pi over 3. Now if I look at the period of the tan, a typical period, and again, we're going to do radians because I see a pi here. So I know it has to be in radians. Typical period is pi radians. And again, we're going to put that over 2. Well, I can't really simplify that. So the period, instead of being pi, which would be typical for tan, it's pi over 2. So I shouldn't say it's always over 2, but it's over B. So the B here is 2. The B here was 3. And phase shift is the same for all of them. You set inside parentheses equal to 0 and solve. Okay, so if I take this 3x plus pi over 2, I'm trying to get a different color here. So if I try to take that and set it equal to 0, that's going to be the phase shift. Same with tan. It doesn't matter what the trig function is. We would take 3x plus pi over 2, set it equal to 0. So if I solve that, I get negative pi over 2. And to get rid of the 3, I can divide by 3, but maybe it's easier to think of it this way. If I multiply it by 1/3, you can see x is going to be negative pi over 6. And that is the phase shift, negative pi over 6. So same thing here. Tan is no different. Set inside a parentheses equal to 0. And we solve. So I get negative pi, divide by 2, negative pi over 2. All right, I'm just going to get rid of this part here so you can see a little bit better. All right, Let's do a couple more here. So now we're actually going to start graphing them. So if I'm looking at number 3, we're going to fill out the left side first. The amplitude, remember, only ones that have amplitude are sine and cosine. So I am going to put an amplitude down, but I'm going to put the positive amplitude because amplitude is the height from middle to top or bottom. Okay. And I'll kind of emphasize that when we draw it. But the amplitude is just positive 4. The negative just means that the shape is going to look like this. It's going to be an upside down cosine. Instead of a hill and a hole, it's going to be a hole and then a hill. All right, vertical shift. All right, so what that means with our graph is that we're going to go down 5 for the vertical shift. So we're going to go 1, 2, 3, 4, 5. And from there, we have to go up 4 and down 4. So let's see, I'm going to try to get rid of this little notch here. Okay, -6, -7, -8, -9. You can see my graph is not perfect, but I'm going to go down to -9 and up to -1. So what I was going to say, it's not perfect, but we just want to we want to be able to at least clearly see where our midline is. So it's going to hover around -3 and it's going to go up to -1 because it's going to go up 4 from there and down 4 from there. So that's what we mean by amplitude. It's from the middle, how high it goes, how low it goes. All right, I feel like I need to straighten that out a teeny bit. Okay, now the period and the phase shift, that's the left, right. That's always the part that's a little bit tougher. So we're gonna take that 2 that's in front of sine, and the directions say to do it in degrees. It says to do it in degrees. So a typical period for sine is 360. I'm going to divide that by b, that 2 there, and I get 180 degrees. So that's the length of a period. Now there is nothing inside the parentheses. I mean, if I wanted to set 2x equal to 0 and solve it, I would still get 0, which just means there's no phase shift. Okay, so there's nothing inside parentheses, so no phase shift. And what that means then, if there's no phase shift, we're going to start at 0 and we're going to end at 0 plus 180. We're going to end at 180. So I'm going to start at 0 and I'm going to end at 180. Like that, right? Halfway in between is 90. So I can either mark it up on the original x-axis. If you wanted to mark it here, that would be okay also. But I'm going to do the original. 0, 180, 90. Halfway in between here is 45. Halfway in between there is 135. Okay. And then, let's try to get rid of these couple little things. Like I said before, this is where it starts. It starts at 0 and it ends at 180. But now you can kind of see inside that yellow box there, that's where we're going to put our graph. And the shape of our graph is a negative sine graph. It is a negative sine graph. So no matter if it's positive or negative, it's going to start in the middle, end in the middle. The middle is the middle. But it's going to go down first and then up. So it's a hole and then a hill. And that is one cycle of sine that has an amplitude of 4, vertical shift of -5, and a period of 180 degrees because we had to do that 360 divided by 2. Okay. Number 4. So this is sine. So it does have an amplitude. The amplitude is 3. The vertical shift is 1. All right, I'm going to try to Nope, I'm not going to bring that down. It's not going to let me do that. I'm going to actually redo the graph here just because then we have a little more room. So if it's at 1, I'm going to go 1, 2, 3 up from there. I'm going to go 1, 2, 3 down from there. So again, if I'm looking at my top and bottom, this is going to be the bottom of my graph. That's going to be the top. And this is going to be the middle because that's the vertical shift. Okay, so we have that part. We're doing this one in radians. It says to do it in radians, but I can also see because they use pi. So sine typically has a radius of 2 pi. Well, we're going to divide it by whatever is in front of x, which is, this is our b. This is our b here, which is just 1. So if there's nothing in front of x, it's just your typical 2 pi period. Now the phase shift is take the inside of the parentheses and set it equal to 0. Negative pi over 4. Okay, so we always start at the phase shift, negative pi over 4, and we end at what the phase shift is, because that's the starting point, plus the period, because if that's the length of one cycle, it's going to end that much later from the beginning. So I'm going to add these two together, but I have to find a common denominator. So common denominator is 4. So 2 is equivalent to 8 over 4. This is the same as an implied negative 1. Negative 1 plus 8 is 7 pi over 4. Okay, 7 pi over 4. So this is where it's going to end. This is where it's going to start. So we're going to start at negative pi over 4. And don't worry too much about where they are on the line. I'm just going to kind of do that. It has to start before 0. But then it's going to end here. And then we're going to estimate, okay, this is about halfway in between. Halfway in between negative 1 and 7 is 3. Well, if you're not sure how to find that, go ahead and add negative 1 plus 7, which is 6. 6 divided by 2 is 3. So 3 over 4. What's halfway in between 3 and 7? Well, you probably know that's 5. What's halfway between negative 1 and 3? Well, it's 1. Okay. I would say I would for sure want to see this, this, and this, and then these notches here. Okay, I for sure want to see the beginning labeled, the end labeled, and the middle labeled, for sure. Okay, then if we're starting at negative 1/4, I don't know, it looks like there's a 1 there. Better get rid of that. There we go. I think I did it maybe as an implied 1, but all right. And then it ends here at 7/4. So my graph is going to go inside the yellow part, And it is a positive sine graph. So a sine looks like this. So it's going to be a hill and a hole. So inside the yellow box with the blue line as the middle, it's going to start in the middle, end in the middle. The middle is the middle, and it's going to go up first, right? This is what our graph is going to look like. It's going to go up first and then down, okay? And so you can see, you know, my scale is not perfect, but at least I can really see how high it goes, how low it goes, where the middle is. I can see where it starts at negative pi over 4. I can see where it ends at 7 pi over 4. Okay, so we're going to finish off with this, and I'll talk about the next page in the next video.